Hi, my name is Diana Sturdy, and today we're going to be learning about implicit differentiation. You should have already learned how to take the derivative of equations involving the variable of x. But today we're going to be learning about how to take the derivative when the function involves both variables x and y. To begin, I'd like to provide you with a definition of implicit differentiation. So, implicit differentiation is needed when we have mixed variables x and y that represent functions that are hidden in the equation. So when we have equations that involve both x and y, when we take the derivative of y, we have to tack on a dy dx. Allow me to explain. If we have within our function, let's say our function is y to the third is equal to x. When we take the derivative of this part, we have to tack on a dy over dx because we have taken the derivative of y. So we use our power rule, bring the 3 in front, subtract a 1, we get 3y squared, and now we have to tack on a dy over dx. Then the derivative of x is just 1, and now we have to solve for dy over dx. That is what the implicit differentiation is what dy over dx is equal to. So we simply divide both sides by 3y squared, and we get that dy over dx is equal to 1 over 3y squared. It's pretty simple. Let's get a harder example. So for our second example, it'll be a little bit more complicated. Let's look at when we have 3x squared plus 3y squared plus y is all equal to x squared. So let's start with taking the derivative of each part. So we do our power rule, and we get 6x plus, power rule again, 6y. But since we just took the derivative of y, we now have to tack on our dy over dx. And then the derivative of y is just 1, but we cannot forget to tack on the dy over dx. And it's all equal to, derivative of x squared is just 2x. So we want to get dy over dx alone. So we're going to subtract a 6x from both sides. And 2x minus 6x is just negative 4x. This is all equal to dy over dx added on to 6y over dy over dx. Let me write this. It's a little messy. 6y dy over dx plus dy over dx is equal to negative 4x. Now we still need to get our dy over dx alone. So what we're going to do here is take out a dy over dx. Dy over dx taken out of this. So we're left with, we take a dy over dx out of that, we get 6y. Out of here we get just 1. It's all equal to negative 4x. And now it's super easy. We just divide by 6y plus 1 over 6y plus 1. And we get, I'll write it nice and clear up here, dy over dx is equal to negative 4x over 6y plus 1. Now let's look at something that's a little bit more applicable to what we've been learning. Let's say that the problem doesn't just ask you to find dy over dx, but it looks something like this. Let's find the slope of a circle. So that would be, let's say, x squared plus y squared is equal to 25. That's our circle equation. And we want to know the slope at the point 3, negative 4. This is our x value. This is our y value. So let's start by taking the derivative here. Do our power rule. We get 2x plus power rule again, 2y. Now we track on our dy over dx. And then this is just 0. So we need to get this alone, the dy over dx. So we subtract 2x from both sides, and we get 2y dy over dx is equal to negative 2x. Then we can divide by 2y, divide both sides by 2y, and we have dy over dx is equal to, the 2's cancel, negative x over y. But now we need to go back up to what the question was asking us. It wants to know the slope of this equation at this point. So now that we took the derivative, it's easy. We can plug in the 3 for our x's and the negative 4 for our y's. So that means the slope at the point 3, negative 4 is simply, we plug in the 3 for the x, so negative 3 over negative 4, which is just equal to 3/4. And that is our answer. Those are the basics of implicit differentiation. I hope that you enjoyed. Like and subscribe.